Hello again, this is page 1 of our work for April Fool's Day, Wednesday. And first we start with some vocabulary. I want to know what these things mean so we can read our textbook and discuss questions. Now, a monomial is the word we give to when you have a variable to a power and something maybe multiplying that variable to a power. And this number can be any real number. It can be positive, negative, decimal, whatever you like. Variable, you can use whatever letter you like, but we typically use an X. The only sort of restrictive part is for it to be called a monomial, the exponent has to be one of these things: 0, 1, 2, 3, etc. In other words, it has to be either a whole number or 0. Can't be a decimal, can't be a negative. If the exponent is that kind of value, then we have what we call a monomial. And of course, a can be 1, a can even be 0 in the strict sense. But if you have any number times a variable to a power where the power is 0, 1, 2, 3, and so on, any of those, then we have what we call a monomial. A binomial is simply a sum of two monomials. So two monomials being added, such as like 3x squared plus 5x to the 9th. Okay. And of course, I used 3 and 5. I could have used negative numbers. I could have used decimals. I'm trying not to be too exotic here. So that's what a binomial is. A trinomial, 3 terms. It's like a binomial, except you got 3 terms. So I'll just make something up here. I'll say 7x to the 4th minus 3x to the 9th plus 4x to the 3rd. Okay, I just made that up. Now I skipped over polynomial because polynomial is the name we can use, the general name for if you got 2, 3, 4, 5, some collection of terms added together. That's what we mean by polynomial. So a sum of monomials would be the definition. Okay, so everything we've written here qualifies as a polynomial, but that's like the open-ended. How many terms are there? If you say polynomial, we don't know, but this is more specific. That means 3 terms, that means 2 terms. There's no fancy name for 4 terms, 5 terms. We just call those polynomials. By descending order, we mean if you have a polynomial expression, a binomial, trinomial, or just something lengthier, descending order means the terms are in order counting downward by their exponents. So like this is not in descending order. If I want to change that to descending order, I would put this first because it's got the higher exponent. 5x to the 9th plus 3x squared. There's the same expression. It's worth exactly the same, but this is like the more polite version and more useful version most of the time, descending order. I do the same thing with this one that I made up. What would we change here? This would be the lead term, 9, 4, 3. That would be counting down. Notice what's happening with the coefficients. They just get carried around like a suitcase out in front. Okay, so again, there's the same expression. but written in the more socially acceptable descending order. Okay? And then I've got this written here. The degree, the next thing to define the degree is simply what's the highest exponent you see. So this example here is 9th degree. This one up here is 4th degree. Okay, and of course before I put them in order, this is still 9th degree because the higher power was 9. Like terms, by like terms in comparing one monomial to another, we have to have the same variable and the same exponent. For instance, here's a x to the 4th, y to the 4th. They have the same exponent, but it's not the same variable, so these are not like terms. If I have x to the 4th and say 5x to the 4th, those are like terms. The coefficient doesn't matter. It's the fact that the variable is the same and the power is the same that makes those like terms. And a coefficient, I've discussed that, used that already. Like the coefficients for this expression, what would the coefficients be? The numbers multiplying the variables. -3, 7, and 4 would be the coefficients there. And when you see these terms in your homework, vertical versus horizontal format, if it tells you to do the adding or subtracting in vertical format, it means arrange stuff in columns. Horizontal, go left to right, working with it the way it's written right here. So if I want to do some adding, I'm only allowed to add like terms. And because of the limitations of my iPhone camera, I'm going to write my answer down here. So as I look for things that can be added, it's this expression plus this expression. I can add the x squares to each other. I'm going to align those like that. And I can add the x's to each other. So this is just my little bookkeeping device. I do this aligning and double underlining to separate, to organize. So 6 of those plus 3 of those, 9x squared, and then 5 and 7, 12x. That's the answer. Now notice when I added these, I didn't make the mistake that a lot of beginners make of adding the exponent. It's not 9x to the 4th. It's 6x squares and 3x squares is 9x squares. Okay, so that's doing it horizontally. If I want to do it vertically, I'll write 6x squared plus 5x, and directly underneath, in vertical columns, I would write the other expression with the like terms organized vertically. So some students prefer this method and find this a little easier. 5x and 7x, that's a plus 12x, and 6x squared and 3x squared, see, it's the same answer. So try this one, and then we'll stop the camera and do a separate video for the next page. So let me do this vertically. I'm going to write it 2x squared minus 5x plus 7, and then right underneath, x squared under the x squared, the x's under the x's, and the integer under the integer. Now I just add the columns. 7 and -1 makes 6, and that's a positive 6, so I'll write a plus 6. That plus sign is important, right? Minus 5 and 11, that's 6. Again, that's positive 6, so I write plus 6x. And 2 and 3 is 5. So there is my answer for exercise number 2. Okay, that's the end of page 1.